Hello and welcome to our next lesson. Today we are looking at our second trigonometric law, which is the cosine law. So again, we will be exploring what the cosine law is and also using it to solve some acute triangles. So first, I want you to consider these two triangles, and are you able to use the sine law in either of these triangles to solve for the unknown sides and angles? First, consider triangle ABC. Here we have two side lengths and the angle between them. To be able to use sine law here, we do have to use this angle here. But we don't have this side length opposite to that angle for us to be able to find that ratio required for sine law. And based on these based on these side lengths that we are given, we don't have, again, enough information to figure out from just sine law what this side length is. So in this triangle ABC, we aren't able to use sine law. Now, in triangle DEF, we actually don't have any of the angles given to us. And because this is not a right angle triangle, again, we don't have enough information based on the tools that we have so far, which is our trig ratios, our Pythagorean theorem, and sine law, to be able to determine any of these angles. So in fact, we also aren't able to use sine law here as well. And that's exactly what is written here. So what is cosine law now? And cosine law will help us solve for both of these triangles. So with cosine law, it relates the sides of a triangle to the cosine of one of its angles. So for example, when we have side lengths C and B, we can actually determine side length A. And the formula for it is A squared is equal to B squared plus C squared. So this is kind of like, it might remind you of the Pythagorean theorem. And then we subtract 2BC, which is again the two side lengths that we are given, and cosine of that angle there. So we can, if we evaluate the right-hand side, we can take the square root to find A. We also have a similar ratio for B squared. So with B squared, when we are solving for this angle or this side length here, now we have A and C. So A squared plus C squared. So pretty much the other two sides. And then minus 2AC, again, these two side lengths, and cosine of B. Now notice here A squared, and then we have cosine of A. Here we have B squared cosine of B. And finally, C squared cosine of C. This is the two values that you have to always match. The side length that you're looking to find has to match with that angle that you input for the cosine. And also consider here, as long as you have, for example, here, I may even have the side lengths given to me, as we saw with this example here with DEF, and I can evaluate A squared, B squared, C squared, as well as minus 2BC, and use that with some algebra to determine what cosine of A is equal to, and take the inverse to find what angle A is. So cosine law will help us in solving for triangles whenever sine law is not suitable, or we don't have enough information for sine law. So let's look at those two examples we had above, and we're going to use sine law to solve for the unknown sides and possibly angles. So here, again, we are looking for A squared, so we use the first formula we saw there. So A squared is going to be equal to B squared, where B squared is here. So this is B, and this is C. So B squared plus C squared, and then minus 2BC, just the product of these two, and then cosine of A, and remember A here is 74 degrees. So substituting our values, and that's precisely what we have. These two should just be B and C here. It doesn't matter in terms of when we substitute here, but we do want to match that the lowercase b is the opposite of the vertex B. So evaluating all of this on the left-hand side, and this is just to show you each of the terms evaluated. So this one I did all together. And if you evaluate this, you get 44.4659. And now taking the square root so that we find A, we get that A is approximately 6.668, or round to one decimal point, 6.7 meters. So now I can label this here 6.7 meters. And now I can solve for either of these angles. And now I actually have an angle and its opposite side length. And here I have to use this calculated value. So if you're unsure, double check your work because you do have to utilize this now. So just make sure you're not carrying forward any errors. So now we can actually use sine law here and evaluate B and C using the ratios. You can also use cosine law as well. It is just a little bit extra work. As you can see, the formula for cosine law might be a little bit more complicated to solve as compared to sine law, which is just a comparison of two ratios. So I did use sine law here. So sine of angle B is going to be the ratio of sine of angle B is to the side length 4.7 here is equal to the sine of angle A, which was 74 degrees, to its side length 6.7. And to solve for angle B, I take the sine inverse, which gives me 42.4. But again, with degrees or angles, we do round to the nearest degree. So just 42 degrees is fine there. So then this here is 42 degrees. Now, for angle C, you can of course use the interior angles of a triangle, or you can use sine law again. So here I did use just the interior angles. So 180 degrees minus 74 degrees and minus 42 degrees is 64 degrees. And that's this angle right here. And again, I do label all of my side lengths and angles on the diagram because this is my concluding statement for these problems. Instead of writing out all the values one by one, I can just label my diagram and I've solved for the triangle. And if you haven't labeled already, please make sure you are labeling all the known values now. Now let's solve the second triangle where we had all the three side lengths. And in this case, you can pick any angle that you want to solve for. Because you have the three side lengths, it really doesn't matter which angle you choose for. So I actually would challenge you to pick an angle that I haven't picked. I will be solving for angle D, but I suggest you try angle E or F and see that you also get the same answer just to practice using cosine law on your own. So if I'm solving for angle D, I do have to make sure that because I will have cosine of D, then the first term here on the left-hand side will be D squared. And this will be equal to E squared plus, oh, there should be a squared here, plus F squared and minus 2EF cosine of D. And remember, we are solving for this D value here. Now, substituting my values, D is 9.2, E is 7.3, and F is 5.8. And so on the left-hand side, or actually I did the isolation first because I wanted to keep all my exact values. So I moved this term to the right hand or left-hand side and it becomes positive. I move the 9.2 squared to the right-hand side and it's now a negative. And because I'm solving for cosine of D, I do divide by this these three terms or this product here, as you can see right there. And now evaluating the numerator and denominator, this is approximately 2.29 over 84.68. And now, taking the cosine inverse of this ratio, I find that D is 88.45, or to the nearest degree, 88 degrees. So I can label that now over here. I'm going to go back to my green. This is 88 degrees. Now I have an angle and its opposite side length, so I can use sine law here. You can use cosine law again, but just to show you a variety, I will be using sine law to solve for angle E. So the ratio of the sine of angle E to its opposite side length, which is 7.3, is equal to the sine of 88 degrees here and its opposite side length, 9.2. And we get that angle E is equal to the sine inverse of this term multiplied by 7.3, which is approximately 52.47 degrees, or if we just round to the nearest degree, 52. Now, because it's 47, we do round down, so that's why it's 52 there. And of course, solving for angle F here, we just subtract and we get 40 degrees. So just labeling again, this is 40 degrees and this is 52 degrees. Yeah. And that's all my unknown angles there. And I was able to use both cosine law, sine law, and just the interior, some of the interior angles of the triangle to determine all my unknown angles. Now, similar to sine law, when do we use cosine law? So, or sorry, before we get into when do you use it, I am also showing you when you are solving for the angle. This is just the formula. Of course, this is just derived from this formula up here. It is just the rearranging that we showed. Where did we show? Oh, that we showed right here. So if you do the isolation just from the formula, then this is just how you find A, B, and C. So as you're starting out, if you want to just practice with these ones, you can, but I do not recommend memorizing these. I just recommend learning the setup of the cosine law from here, and then being able to derive A, B, and C just from algebraic manipulation by rearranging, moving the terms over, and dividing through by the coefficient to solve for each of the angles. But just so we do get practice with these formulas as well, assume that a triangle has side lengths 4, 6, and 7 centimeters, and we're asked to find the measure of the angle opposite to each side length. So starting with angle A, and I did define each of the side lengths as A, B, C with lowercase a, B, C just to help me with the angle that I want to find here. So when I'm finding angle A, because I defined a lowercase a as 7 centimeters, then I know that this A is going to be 7 centimeters. And for B and C, it doesn't matter which one you use in the order, but because I have defined them, I followed the same order there because B was 4, then you see 4 squared here where B squared was. And of course, substituting those values there, as you can see, I get cosine inverse of 3 over 48, which is 86 degrees. And for angle B, now the side length opposite to angle B is 4 centimeters. So of course the minus that I have there is going to correspond to minus 4 squared. And the other two doesn't matter, 7 squared and 6 squared, as long as you have both included there. And we get cosine inverse of 69 over 84, which is 35 degrees. And finally, angle C. Here I did use again the cosine law here to show you. So we end up with cosine inverse of 29 over 56, which is 59 degrees. But you could have also used the sum of the interior angles. And of course, we can double check that if you add these three up, you do end up with 180 degrees. And just to show you what this would look like, perhaps something like this. This would be our 86-degree angle. This is A, so then this would be 7 centimeters. Then we can have this as 59 degrees, which is C. And so this side length is going to be 6 centimeters. And finally, this is 4 centimeters, and this will be our 35-degree angle, and this is vertex B. So that's kind of a approximate visual of what the triangle might look like. So now that's where we have when to use cosine law. So similar to sine law, we want to know when the cases for cosine law are. So it's pretty much the two examples we saw at the beginning and the two that we solved. So one is if you have the side angle side, so the angle between two sides. And of course, you're pretty much checking, can I apply sine law? And you should see right away that given this angle, you don't have the opposite side length, so you don't have this ratio to apply sine law. So then we we have to use cosine law. And the other example, which is when you have the three side lengths, so SSS. And in this case, again, we don't have any angles to be able to form the ratios for sine law. So then we are using cosine law here to determine one of the angles. Now, once you have one of the angles, or in this case, you have the opposite side length in which you can form one of the ratios for sine law, then by all means continue to use sine law for the other parts. You're not obligated to use cosine law unless the question has explicitly asked you to use cosine law all the way through. So again, we just saw these two examples. So this is the case of SAS, where you have the side length, the angle in between, and another side length, and SSS, where you have the three side lengths. And we just saw how to solve for either of these two triangles. And that was it for our cosine law. So it is a bit of a shorter lesson, but I want you to get lots of practice using cosine law, so complete the practice step below. You can always check Google Classroom for additional tasks, and as always, don't hesitate to reach out if you have any questions, and I'll see you all in our next class.